Make sure the audio's up and we're good and we're mixing. All right. Welcome back. How you doing? Hopefully we are good. We're like this. Levels. Yeah. Okay. All right. Welcome back. How you doing? I hope you've had a good week. We're back here on the stream doing some Haskell hacking. So if this is your first time tuning in, welcome. I am the Agent Ultra, and on this channel and on the stream, we basically work on practical Haskell projects. So we're not like learning Haskell from like first beginnings, but we're working on things to show you what it's like to work on real Haskell programming. Because I don't know, when I first started this stream, people didn't believe enough people didn't believe that Haskell's like a thing you could do real software development in. So, but it is, and we're making a Haskell clone of Asteroids. And if you haven't seen that before, this is what it looks like. We have different menu scenes and a game that it works. You can fire bullets, you can crash into asteroids, you get a score, you get a game over, you can start a new game and try to beat your old score. Pretty cool. Okay. And last week, I believe we said we tweaked some of the gameplay, we're going to work on sound today, so that's what we're going to do. I did manage to get sound working under WSL2. So that's not going to be an issue this week. So let's get our builder going. We're going to go stack build fast and put our file watcher on so it just keeps rebuilding. All right, I'm going to make sure that I'm watching your chat, seeing how you're doing. In case anybody has questions, feel free to pop in with any questions you have at any point in time. I love chatting about whatever. Hopefully the font size is going to be big enough for everyone this week as well. So let me know. Let's open up the game. No, let's look at our stashes because we stashed some of the audio stuff that we were working on. We had some code already written for this. Looks like we got a diff to resolve. So we changed some stuff. And that's pretty easy to merge. So it's 3.0 we want. And 150. And there we go. Get rid of that part. And there. And nothing else to merge. Mark it as resolved. We are good. Yeah. Okay, so we all compile. But last time we tried to do the audio code, we got seg faults because the shared library that the C libraries use couldn't initialize because we didn't have enough sound system installed and set up. I believe that's fixed under WSL2 now, so a more recent one. I was just running on an old one. Okay, that's better. That's a different error. So this is just the file. Binary file is not right. I think that's because the name of our file is not laser sound, but laser shoot.wave, as you see up here. So let's go over to laser sound and change that to laser shoot.wave. That should be good. Okay, now we should be able to run the game as before. Everything's good. Yeah. Okay, code out of that. Super. Only we didn't hear any sounds yet. And that's because we are just loading the sound so far, I believe, in this code. If we look at the changes to game, We added the bullet sound as a chunk in at the game state, so you add the chunk to the game state when you reload it. And yeah, crucially, we have open audio, we open the mixer, set the bullet sound, load it, and in at the game state with that new sound, and then we make sure to close audio after opening it. I think the other thing we might need to do is also free that sound. Mixer close audio might do that for us. Certainly it will by the time the process closes anyway, 'cause we're not unloading at any point during the main game loop. So the operating system ought to clear that out for us. But could be good citizens to just make sure that we do that. SDL mixer. Let's get our API here. Oh yeah, free. Freeze the values memory. It should no longer be used. Note that you shouldn't free those values that are currently playing. What if there's a way to wait for everything to stop playing? Okie doke. Let's see. Turn the music down. Let's snitch. Yeah, okay. Well, I mean, free is fine. We can do that here. If we jump over to run, ba-bow. Let's just see if this should work, I think, hopefully. Mixer.free. Bullet sound. Okay. Other than that, let's actually just commit that and start here. Add SDL mixer and initialize the library and load a load a sound. Cool, you can kill that stash. Sweet. All right, now we need to play it. Okay, we can play limit and play. Play a chunk once using the first available channel. Okay, play on, same as play. Plays the chunk using a given channel a number of times. If all channels is used, then plays the chunk using the first available channel instead. Returns the channel that was used. So that looks like that gives us kind of a good amount of control about channels. Whereas play just kind of picks one for us, the first available. Let's just try that for now. I don't think we're going to have to get too involved with channels for this game. but good to know that it's there. So play, the type signature for play happens in an IO context that's given by this monad IO M thing. It doesn't tell us what monad it is, so that we can like create our own monad stack if we wanted to, like an MTL style approach or what have you, or our own like custom big fat monad. But we have to have IO at the bottom of this monad because it runs in IO. That means in order for us to invoke play and to use it, we're going to have to use it in an IO context, like run or loop. This will be fine for now, just to test it out. But I think we're going to want to change it so that different scenes can use different sounds, which we can't really do from here in the loop, I don't think. So let's just add a quick little test code when fire button pressed, space pressed. We'll play the game state bullet sound. Oh, let's mixer.play, sorry. Okay. Right here. There we go. Sound. I'm gonna turn let's pause the music for a second here. So whenever I press the little, we get our little sound effect. Hopefully that's coming through on the mix pretty well. Just check OBS, yeah. Yeah, okay. All right, so it only happens when I press it on the frame, of course, because that's just our test code, but yeah. Cool. So I hold it down, obviously I'm not going to get any sounds and continuously firing, whatever, blah, blah, blah. We're going to solve that problem next. Interesting that I'm getting this segmentation fault thing. When I quit normally, it's fine. If I press Q, that's fine. Huh. Weird. Wonder why that's happening. Anywho, yeah, that's cool. That works. So we can play sounds. So this is where we're going to have to get a little bit clever, I think, with our design of our audio subsystem for this game. Because play only works in an IO context, and we want to be able to play this sound when the bullet is created, when we fire the bullet. All right. So that happens. Fire bullet. Here. And you notice fire bullet obviously is a pure function. It doesn't have IO anywhere in its type signature, so we can't play sounds here. We call fire bullet here inside update. Update also is a pure function. There's no IO here, so we can't use the play function. What are we going to do? Well, there's two approaches to this, I think. We could either go the route of, adding IO everywhere that we want to be able to use IO functions. That would be one way of doing things. but I wouldn't recommend it. I like having I/O constrained and contained to a very small surface area. As you notice, if you looked at the test files, like our unit tests and stuff, it's pretty straightforward to test things like collisions and whatnot. And even update, it's a pretty big function, but because it's a pretty big state to cover, but we could write tests for this as well. And they would be very, very easy to write and to work with. Because it's pure code, it's not inside I/O. So I like to keep the surface area of I/O fairly small, fairly contained. And that's what we're going to do. So that, we can also like test our scenes and how they work. And things like that. But we want to be able to play, we want different scenes also to play, like handle sounds differently. Like maybe we want a different sound effect for the menu when you select different menu items, and then like a little sound for when you click start and things like that. Maybe we want different music for different scenes and whatnot. So how do we get those scenes to be able to trigger sound effects without extending I/O throughout our code, our nice, clean, pure code base? For that, we're going to have to use, I think, some kind of event system. So we'll add something to the game state that will collect these events so that all our pure functions that just play with the game state can add events to the game state. And then where we do I/O actions, i.e. up in loop, we can execute those events. Right? So if we think of it in terms of layers, we have this like kind of this impure I/O layer at the top that talks to our platform, our computer, right? And it will do all of the things like load files and play audio, play sound files, right? Then underneath this layer, we'll have our game engine, which is all nice pure code. And in here, in the game engine, we're not going to have any I/O. We're going to have like just the game state, blah, 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 blah. Look at my fancy mouse handwriting. Super cool. And this game state function, since it can't do I/O, needs to have a way to signal to the I/O layer, do this thing. Right? So we can use a data structure to represent this message. And this message will just say like, play this sound. Right? Play X sound, what have you. And then we can have functions in here that kind of like are within the I/O layer that can understand this, can interpret this message and then can do that thing. So it can call play with the right message and that sort of stuff. Right, that way we can keep the I/O layer in its place, separate from the rest of our code. And we don't have to mush around and mix things up and get everything all entangled and whatnot. I think that's going to be my approach for this. So let us start with our structure. Let's just use a list for our events, and we'll use some kind of event type. Yeah. Where do we want to put it? Maybe under here. Okay. So what do we call them? We call them I/O event. I think something like that. Play sound. We can give it a name. And if we want, let's just stick with that for now. That should be good enough. Not get ahead of ourselves. We'll drive our normal type classes for that. I know. You want it to be a new type for now. Okay. So let's play sound. So now we need a place to collect these I/O events in our game state. Look at our game state definition. Add a field, game state, I/O events. Make it a list of I/O events. And then we're going to have to initialize in our init game state setup. Game state I/O events. And we'll initialize that to the empty list. Do it with a literal, we can even do it with just an empty. Be a little consistent. Okay. That's that part. Then, what do we need to do? We need to interpret those events, and we need to be able to put I/O events in there. We could have a helper function for it. That event. It'll take game state, I/O event, and return new game state. Since game state's on the left here, we're not going to use record wildcards because we return it on the right. And as I noticed many times, record wildcards doesn't seem to play really, really well with that. And somehow my keyboard state has gotten messed up again. Thanks, Windows. Our toys. Yeah. I don't know why that happens, but it's super annoying when it does. Okay, game state. I/O event. So then we know what we want to return. GS where game state I/O events is equal to and we'll plop them on the head of the list. And then we'll just do them in list order when we get to the loop. So the game state I/O events, geez. And then we'll put event on the head. Cool. So we have a way of adding the I/O events, and now we need a function for processing the I/O events and interpreting them. So we'll run I/O events. Takes a game state, does some I/O. So all of these I/O events will just have to do something, but not return. We can't collect the results of them. So our scenes can tell it, our I/O layer, to play a sound, but it can't say, like, what channel did you play that on? I mean, we could maybe design a system that would let us model, be able to model like some way of returning the values from the effects that were run somehow. But I think this will be good enough for our game here. So run IO events. Here we can use our record wildcards to deconstruct game state. Okay, and then what we do here is we can just we can iterate over them if we want to, like this way. And then we can lambda case over, and we can do play sound. And so if we look at the type hole here, it's just an IO of whatever. Really going to be IO of unit. So yeah, for now we can just hard code this and ignore S for now, because we might want to change that up in a minute. Kind of an affordance. Game, we can do mixer.play, game state bullet sound. Now we have a way of interpreting our IO events. However, we want to process the IO events once and then clear out this list. So I think what we should do here is actually make this return the game state. Then we return. So we'll pull that into scope. And we'll just make it where game state bullet sound, or game state IO events is an empty. Okay, that'll be better. Okay, so let's add run IO events to loop. What's up here? So we'll run it after running the scene. So the scene has a chance to add events this frame to process. We'll process them before looping. So we'll do state prime prime. Run IO events. State prime. And then loop on state prime prime. Now that should all compile. We don't have anything that plays the sound yet, because we have to add the play event. So we have to use this add event function in our scene. So let's add it to the main scene, which is our gameplay scene. In the update function here. So we fire bullet. And we can compose this with our add event function. Oh, wait, no, because that bullets is a deck. That's right. So that's just going to update the bullets. That's fine. We need to add it here somewhere. Let's see. Let us... We're basically going to have the same thing here. This is not a monadic context. What we could do? We could do... Just do it the ugly way. Hoist and see if we can make it prettier. We can add IO event. Takes a game state. The IO event we want to add. So that'll be play sound. Sorry, add event. Although we only want to do this if the key, the fire button condition is key down and bullet timer is 0. Otherwise, just next state, don't do anything. Okay, let's see if that works. Okay, bang. Game works as before. There we go. Boom, game over. Cool. So it works. So that's kind of a way we could do. We can keep our code pure and then just kind of keep the the IO layer for doing IO stuff separate from the rest of our stuff. Code's getting, let's see if we can clean this up a little bit. Let's just create a commit. Work in progress. Add IO event. So this system enables pure code to trigger IO actions in the IO layer. Okay. Which one am I on here? There we go. Barp, barp, barp. Okay. I think we could maybe clean this up if we flip around the arguments to add event, maybe. Hmm. It's still kind of conditional. We could at least give the expression a name. We should fire a bullet. It's one tiny thing we can do. That's going to be kind of annoying to use if we want to have multiple effects trigger. Because then we have to be like, okay, and then for the next one, we're going to do... Like, imagine if we had multiple sounds going on in the scene, like, for asteroid collisions, right? The next one we add is going to be like, all right, well, next state prime prime is going to be, if we should add this, if we detected a collision. Well, we might be able to do it and handle collision results. Oh, no, not really. No. But kind of. Yeah, well, I mean, here I would probably just add the event, game state IO events directly. Otherwise, I would do add event here with our event and make game state the last argument, which maybe it should be. All right. The code might look like something like that. Oops, sorry, there's been a bunch of chat going on. Sorry, chat. I've been so taken up. Whimsically made. Thank you. There's no game music yet. I have been playing some stuff, but let me just turn it up a snitch. Hopefully that's better. Wow, a raid. Welcome, raid. I'm just catching up on chat. What a surprise. Thanks everybody for dropping by. Ahoy hoy. Okay, hopefully I've turned it up a little bit. Hopefully that's coming in now, nice and clear. So, some questions. Awesome. Let's look into them. I need to have all the symbols listed. I'm curious what a scene is, for example. Cool, cool. All right, side effects. Yes, ignoring chat. I'm sorry, chat. I'm here. I'm here. Okay. Yeah, in Haskell we like IO a lot. Actually, we love side effects. We use them all the time because programs wouldn't be very useful without them. Clearly. Or at least running them. If you're interested in running programs for doing work, whatever, right? Wouldn't be very useful without effects. We just like to control them and know where they're happening. And that can lead to cleaner code and nicer to maintain code and stuff like that. So keeping concerns separate is a nice thing to do. I'm going to some lengths here to maintain that separation where in a language that allows kind of IO effects happening anywhere in your program that you want them to. You have a little bit more free reign to just kind of put them wherever, which can, if you're not disciplined, lead to spaghetti kind of code, right? So it's generally good practice to do this anyway. Haskell just can kind of force you to, or at least make it the easiest way of doing things. If that makes sense. Yes, so this code is getting a little bit hairy because I'm not using I'm using almost no abstractions right now. So the state handling, for example, there's a lot of functions that go from game state to game state. Nice, pure, plain old function, very, very simple to deal with. But I'm noticing a number of places where it's starting to get kind of annoying and hard to maintain on its own. That's kind of my beef with simplicity and being kind of, I don't know, overly simple with it, is that it can introduce its own kind of complexity. Right, so at a certain point, overly simple code itself becomes hard to read and maintain. And you have to do something about it. Which we might get to, but this game's getting very, very close to being finished. And so I haven't really gone too far to use any or introduce any of those kinds of abstractions because I think the scope of the game is small enough. We might get away with it. But for something bigger than this, where the state space is much larger, I'd probably start thinking about structuring it a little bit more cleanly and separating things out. But for now, we're using a very, very simple, very, very straightforward I/O system that's just going to let pure code trigger I/O events and like trigger I/O actions and things like that by using this sort of event type of structure. Yeah, we can do stuff like that for sure. Yeah, we can take diffs of the previous state, the next state, figure out what to do. Here, I'm just using an event sort of thing where we just have pure code that can just queue up things to run, and then we just have a function that just goes ahead and runs them. I'm just playing around with the API for adding new events to the game state, and like it's kind of meh. But we're not going to have too many of them, so messing around with it manually might be fine enough. Yeah, spoken like a true web dev. That's all good. But I mean, there's a lot of patterns in functional programming that is inspired from, so you're in good company. So the fire bullet stuff. Yeah, I think the bullet collision code is probably the ugliest part of this. And firing bullets isn't too bad. I think the data structure I'm using for bullets and asteroids, this deck is a double-ended queue, the doubly linked list. We're not really using this to its full advantage all that much in this code. So if I wanted to take another kind of cleanup pass on this, I might change this out for like a vector or something like that instead. But it's fine enough for now. But yeah, the collision stuff is kind of the grossest part. And again, that's because I'm like doing things in the simplest way possible, where I'm not like introducing too many new data structures. We're just using a plain, really brute force algorithm for collision detection. It's not the greatest, but it's good enough for this because like the space of the number of collisions is really, really small anyway. So even if we had like a crappy algorithm that's poorly performing, it doesn't really matter. All good, whimsically made. Thanks for stopping by again and bringing a raid with you. Ah, you were Slippy Goat before. Cool, cool. Well then, I shall continue on. So, we were just, oh yeah, we were just investigating hooking. We had it working, we just needed to hook up. We're just refactoring some code back down to try and make it a little bit more meh. But yeah, if anybody else has any other questions, feel free to pipe in. I'm here for you. Okay. So yeah, this is the API. This is the part of the API for like that add event function that I'm not super jazzed about this. And in fact, this whole function here update is getting quite long, right? And especially as we get near the end, we're getting like state prime, and then we're getting next state, and when we see this kind of pattern, like this is begging for a monad. Like a monad will make this much cleaner. But I just didn't. When we were getting into this, I didn't bring that in. We could still do that refactoring, maybe, at some point. Or I could leave it up as an exercise to the reader. We've covered monads quite a bit in different contexts and different programs. All right, so how would it look with a monad, by the way? That's good. So if it was a monad, We could write functions here that manipulate the state, and we wouldn't have to bind the next state to a new name and keep passing it down. So if we wanted to do this update position code here, for example, or no, let's say handle collision results. Right, this would just be handle collision results. Blah, 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 blah. And the next line would do something else with the state and something else with the state. And they would just chain together. And the state would just get updated by each of them. And we wouldn't have to bind all these extra steps and pass them to other functions. Yeah, exactly. All right, so that's kind of like the do notation under the hood is like, they call it syntactic sugar for a reason. Because that's what it is. It's not super, like, need to know in order to use it kind of stuff, but that's kind of what it's doing under the hood, is it's chaining together these monad functions. It's doing the bind, basically, under the hood. It's hiding the bind under the under that left pointy arrow. So you see it in our IO code, for example. This is doing a bind, right? And on the right-hand side of that operator, we can put any IO returning function. And if the IO returning function doesn't return anything, because this doesn't return anything, it just returns unit, then we can just have a plain old IO function like open audio mixer here. And that's an IO unit function, the type of that. And we can just do it, and then we go to the next line, right? But in between each of these lines, there's actually like an implicit bind between each of them, so it's doing stuff. It just makes the syntax a lot nicer and cleans things up and makes it easier to work with, which is nice. Notation kind of matters, and syntax kind of matters. So if we were doing this for state instead of IO, it's a similar sort of thing. It would clean up this code and make it look nice and vertical, move things over to the left a little bit, reduce the number of binds, intermediate binds that we have, these intermediate variables that are kind of ugly and gross. Okay. So that's kind of the code smell I think you get when you're like, should I use a monad? Should I not use a monad? Like when you have a lot of intermediate variables that you want to like, that aren't necessary. They're cluttering things up. Yeah, and there's some libraries in OCaml that do use like a monadic interface for stuff. I think a lot of the Jane Street libraries do have that, if I'm not mistaken. It's been a while since I've done some OCaml stuff, but yeah, it might have its own syntax for it, and its own syntax sugar, maybe provided by libraries. Haskell has it kind of built in. Are they still snobby? I guess. I don't know. You probably end up feeling a little bit snobby when you work there because you make so much freaking money. It's hard not to. But if you're there just for the computer science and the hard challenges, try not to let it make you snobby, I guess. Be cool, man. Be cool. Okay. This all still compiles, yeah. I think that's probably about as much as we can like clean up the code. Really, it's just kind of like name the common expression and then use it a couple of times. Because I think the next state stuff can only really be cleaned up with that big refactor. So if it happens one more time, maybe two more times, I'm gonna like drop the hammer on this and do that. so that it's nicer to work with. Okay. Yeah, refactor that. Squash those down, reword that. Good. Implement the play sound event. Okay. So there's part of this that isn't fully implemented yet, which is we basically ignore the parameter to play sound when we call mixer.play. I'm anticipating we're going to have like many more sounds, or at least a handful more. Not just bullet sound, but we're probably going to have like thruster sounds, some explosions. The menu, we might want some sounds for the menu. And like maybe the game over scene if you decide to start a new game. It's probably have like a little okay sound. So let's create a mapping of names to sounds and store that mapping in the game state. And then that way it can just be a lookup for that name. And then in the case where we don't find that name in the map, we can just do nothing. Maybe we can even like have like a debug mode where it would log it out, but in our production code, it'll just like, I don't know. It's not working. And then we can let QA kind of argue about what should happen there. So I'm going to go to our game state definition here. And yeah, let's call it game state sound map. It should be a map from text to chunk. Okay, and I don't have the map type in scope, so we're gonna have to fix that. I think we have containers in our packages. But I guess we're about to find out. Data. Yeah, we have vector restorable, so I think we do. So import data.map.strict map. And then we'll go to the init game state. Now, when we want to init the game state and give it our sound map, what are we going to put there? We have an input chunk. We should probably make this, we can either make it a map and just tell the caller, construct the map for us and give it to us. That's probably fine. Yeah, because the only other thing I could think of is that we would like, define the map this way, but that's silly. It's the same thing as map. We would just be calling the constructor on it. So we could just be like, give us this map. Just tell it, you give it to us. We'll add it. We have a type error though. We can't load it. It is hidden in containers. Okay. So we gotta fix our package definition. And then we can get rid of game state bullet sound. So let's just fix all the type errors. We still want to keep that. We're just not going to send it here. So we're going to put a hole here. And we'll create this from list. Call it fire bullet. I like the dash convention. Okay. I think we're going to change up the music. No, no. Let's try this channel. Okay, so that's our sound map. Type error here, game state bullet sound. Yes, we have to get rid of that. That'll fix that type error. And then this one. Okay, so this one is where we can actually implement it. So this will be the sound name. And then we're going to look up, I think is the name, the thing of it. Takes the key. So it'll be sound name and the map, game state sound map. If we don't find anything, we'll just do nothing. But otherwise, mixer.play chunk. Okay. All right, so then when we go play sound, right, we have foo here, so it should do nothing. All right, it fires, no sound. What if we change that to our fire bullet? And then we get sound. Perfect. Okay, so let's commit that. Add sound map. Cool. All right, let's go make some more sounds. Let's see. We got a laser shoot. We need explosion. That's pretty good. Let's use that. I don't want to serialize. I want to get the sample. Explosion.wave. And let's get another one for the small asteroid blowups. That's okay. Yeah. Close. Ah, there we go. No. There we go. That's pretty good. Okay, and what else do we need? We need a kind of a thruster sound, maybe. Oh, that one's going to be tricky. So that one we're going to have to play like continuously, and we haven't done continuous sounds yet. We'll have to figure out how to do that. So let's just go ahead and add the explosion ones. It's good enough. No amount. C. Desktop. No, downloads. Explosion. Wave. I'll add it to assets. Sounds. Big explosion. And the other explosion to small explosion. Oops. Okay, there we go. Okay. So then we have to, in our run function, load those sounds. Assets, sounds, small explosion, dot wave. And What do we call it? Large or big? Big. Good. So we haven't used those yet, so let's add them to our list. I'm going to pull this over to the left a little bit. Fuck you out. There you go. Small explosion. And big explosion. Good. Okay. Get some music going for a bit. So now they're in our sound map, and we should be able to add some more sound events to our event queue and get them fired off. So we have handle collision. This is where we want to fire off the figure out if we need to fire off the sound or not. And so handle collision. This is bullet and asteroid collisions, this case here. So this is where we've detected one and we're doing something about it. So we're also going to add the sound. IO events. And we'll add the play sound event. Something. We're going to have to figure out what to put here, because there's different sizes. We'll figure that out in a second. And then game state IO events, I think should be that. It's fine. Okay. And then what this should be in that hole. This might not be the place to do it. Because we bundle up all of the asteroid collisions that have happened. And we kind of want to play a sound for every single one that happens. So if we get multiple asteroids that somehow blow up in the same frame, we only really have to trigger one explosion sound. It's just figuring out what happened to my Emacs. It's just figuring out which one to use. We have big or small. Maybe what we could do is just put the big one in there for now and figure out how to do that. Otherwise, we return the collision results from check asteroid collisions. We could add the information here. I mean, realistically, we're going to get maybe a big, maybe a small. In one frame, at most. Because if we explode magically 3 in the same frame, then we only really need to play the one sound, right? Because it's triggering at the same time. It's just going to make it loud. So, we could update our collision result with the data we need to fill in that hole. We could have like we have a data structure in there. We could have a list in there. We could just have an enumeration for the different cases of which sound or sounds to play. What would that even look like? Let's just say that if we have we can put the asteroid size in here. And let's just say if we blow up a large asteroid, this frame, then we'll just play the big explodey sound. Otherwise, we'll blow up the little one. And that's that. And then we'll play the little sound, and then it'll just take precedence. So if we somehow detect 2, we'll just play the big one. We'll prefer the biggest explosion sound because that's cooler. So I'm gonna put that there. The size. Asteroid size is the type. Okay. Okay. So we handle the collision. We'll have to pull out the size. And then we'll have to use size. Let's see. Oh yeah, we'll use size here to figure out what the play event it should be. Yeah, that's right. Game state, IO events. asteroid sound from size. And game state IO events of game state. And then if we have large, big explosion. Yep, okay. That needs to be fixed by putting those in parentheses. Okay, and then our check code needs to be updated. Ugh. Ugh, this is the worst part. That's okay. It's still not a huge function. It's just hard to follow. Okay, so we have to return something for the hole here, which means we need to bring something in scope in this let binding in order to fill that hole in. We'll call it Sizz. We'll put it in here. So fold L prime needs to be updated for handle bullet collision. Asteroid size. So that needs to be pulled in scope there. And when we snuck together the next state, we need to give it something. Or we build, sorry, when we return the next state, we got to give something for the next asteroid size. Which means we got to pull it out from Go. Call it Sizz prime. Means Go needs to be updated. And it's going to return an asteroid size. You might not need the, well, yeah, because Go's going to have to compare the asteroid size to figure out which asteroid size to return. Oh, but it'll get that from the collision detection. So, yeah, it doesn't need it as input, but it does have to return it. But if we don't have one, then in our empty case, we can't return anything for it. So, yeah, we're going to need it as input. That doesn't go there. It goes, yeah, in this tuple. Okay. Which means this case of Go also needs to pull out the size parameter here. And now we're at the smallest case. So we have is colliding otherwise. So we are colliding A, B. B is our bullet, A is our asteroid. And this is where we can say if the asteroid is bigger than the inputs, if this colliding asteroid side is bigger than the input size, then return this asteroid's size. And that's the only case, otherwise just return small. If this isn't already big. So how do I do that? Say I'll get size. Next size might make sense. Hopefully to future me. A and sis. And we'll just make that a where-bound function here. Get next size up. Asteroid. Asteroid size. And we need to return it asteroid size. We'll pull in asteroid. We'll pull apart asteroid with the record wildcards, and we'll get our size. And where the asteroid size is equal to size, and size is small. Do it this way. Let's do it this way. It's big. An asteroid size is equal to big, then just big. Otherwise, big. We have small as the next case, and if asteroid size is equal to big, then it's big. Otherwise, small. And we're just keep the size unchanged. Now one more problem here. The initial size, small. Now, this is going to return a size no matter what, because of the way we've defined this. And collision results. We have collision, bullet and asteroid collisions. Int could be 0 or negative. It's kind of a silly type, but it is what it is. And let's see. Check asteroid collisions, ship collisions. Handle collision results. So presumably this will be the empty list if there are no collision results to process this frame. Do we check num calls? Yeah, we use that for scoring, updating spawn factor and spawn delta. We should probably also use that for playing the sound events. So we only want to do this case where the number of collisions this frame is non-zero. Play a sound. If it doesn't equal to 0, then it should be this expression here. Otherwise, nothing. Okay, so it builds, it compiles. Let's pause the music and test out our explosion sounds. See how that's going. And then I think we are going to have to wrap up for the evening shortly. So let's check it out. So there's our... Oh, got a game over before I even got a chance to blow up an asteroid. I'm good at this game. There's our explosion sound. There's our big explosion sound. Yeah, that works nicely. Wunderbar. Ah, perfect. That works great. Let's add those. Let's add those changes. Super. Let's just review our thing here. So now we have more sounds. A few more. I think we could maybe do something about our sound map. Have some like automate some code that can automate cleaning up things and make creating and loading the sounds more straightforward. But that's good enough for now. It's not a huge number of sounds, so it's okay to manually do that in the code for now. Then we update our collision code to add some IO events, some of our play sound events in the case where we have more than one collision detected. We had to update our collision code to detect that which sound to play, but that works too. So when we get a big asteroid collision detected, then we blow up a big asteroid, that kind of thing. We could, because this is mostly pure code, we could actually write unit tests for our edge cases where we wanted to be able to detect which sound would be played if we had multiple asteroid collisions happening. Probably could have started with that, but It's possible. It's there. But this code looks pretty okay. So get next size up is kind of like a little funky. But in the case where the asteroid size we have in the state that we're folding over is big, we already have a big, then we're only ever going to get big out of it. So in fact, that kind of makes this code a little redundant. We should probably clean this up. Right, if this is big, we don't even care what's an asteroid. It's just big. If it's small, though, we do matter. Because if it's big, we want to go up to big. Otherwise, let's leave it at small. Super. Okay, that's good. That's nice. I like it. And we'll commit that. Add asteroid explosion sounds. Pretty self-explanatory. Booyah. Let's push that up to master. So, thanks Raid for joining me. If this is your first time checking out this stream, welcome. I hope you enjoyed yourself. You can find all the code for this project on GitHub under Agent Ultra / Asteroids. This is where all the code is. You can check it out, build it yourself, see if you can get it working on your platform. I've been mostly working on this on Linux, so no guarantees if it'll work on Windows or not, or Mac, but let me know. Maybe create a little issue there. Because I think the next stage for this project, after we add a couple more sounds and a little bit of polish, is to make optimized builds. So we're going to do a little bit of profiling, making sure that that our memory usage is appropriate and good and well constrained, and so that we just don't have any unexpected performance issues. And packaging. So making sure we can build this game for Windows, Linux, and Mac, say, probably our three main platforms we'll be able to target easily from Haskell. Other platforms, if we want to target switches and stuff, we'd have to port GHC's runtime, which I'm not going to do. But yeah, that's in theory possible. But we're not going to focus on that on the stream. So that'll probably wrap up this project. So I think we've got maybe a few more weeks before we can start looking towards what we're going to work on next on this stream. I have a few ideas, but if you ever have ideas of your own, you can reach me on the Fediverse on Mastodon. I'm on types.pl as Agent Ultra. You can also check out this cool link up here, declarative.tv. There's a Discord server link on that site that brings you to our Discord server, where we have a channel for this stream and channels for other cool people who are also doing programming and streaming in other cool functional programming languages and declarative style programming languages. It's a big tent, a lot of fun folks. And so you can check that out there and leave your comment, your idea, or your suggestion in our Discord channel as well. That's what I was trying to get at. So that's what I got for this week. I usually do these streams every Tuesday evening around 10 after 8 in the evening on the Eastern time zone. If you're following here on Twitch, give us a follow, and then you'll get, all the updates when I go live. Sometimes I do surprise streams and things like that. If you're in a different time zone, you're watching from my YouTube channel, you know what to do there as well. So thanks for following along, and hopefully see you next week. May your monads be free and your types always check, and we'll see you soon.